look at this example. I already explained as a question, so just draw a graph to show what's happening here. So there are two logs, right? They're both floating on top of water. So the log, both logs should be having the same mass. They're identical, so they're both having the same. And then there's a lumberjack. It's starting from here. And running. Okay, so it's running from here. And that's a process. Starting from here and takes some time. It's getting here, right? And getting here. And then it's gonna jump to the second one, and the rest are on the second one. So that's the process. So we know the velocity here equals 3.6 meters per second. Okay. And then we know person is m1. So the log is m2, and their value is 98 g for m1, 230 kg for the log. Okay, question 1. What is the velocity of the first log just before the lumberjack jumps off? Okay, so you have to take look at this kind of question from this perspective of two objects interacting. And whenever it's a two objects, it's a system, and when you have to apply the conservation of momentum, and then the system has to be in an isolated situation where it's not. But look at it, it says here, neglect any friction and resistance between the logs and water. That's the condition. Remind you that yes, you can treat this as an isolated system. So in that case, it means you have the momentum conserved. So you should have m1 v1 initial plus m2 v2 initial equals m1 v1 final plus m2 v2 final. Okay, let's check all this number carefully. A lot of them are simply 0. So initially, the lumberjack is standing at rest at one end, so this is gone. This is v initial equals 0, so this is gone. v2 initial, v2, it means the velocity of the log initially, of course, at rest as well, gone. And then v1 final, that's exactly 3.6 of the person at the end of the running. And the v2 final, which is the one we need to find out. Okay, very simple here. 0 on the left side. The right side m1 is 98. v1 is 3.6, and then plus 230, that's m2, and then times v2 final. Okay, that's a simple equation. Just you can solve v2 final equals this one over becomes negative, so negative 98 times 3.6 divided by 230 equals 1.5 meter per second. Okay, that's an easy calculation. Okay, now look at this. This one is a different case. No, first, sorry. little mistake here. So this one should be negative 1.5. 1.5 actually 3 meter per second. To explain the negative sign, it must mean it's opposite direction to the 3.6, which makes sense. If the person is running to this direction, it must push. Okay, while the lumberjack is running, his foot is pushing the log backwards, right? So eventually, so you should have negative velocity of the log. Okay, now let's jump to the second question, asking for if the lumberjack jump onto the log and rest on the log, so what's going to be the velocity of both? Okay, so now first of all, you try to understand, like someone asked me, would the lumberjack having projectile motion like this? Yes, it should be, but we don't consider that effect. We only consider the horizontal velocity. Okay, so we assume it's the velocity that it doesn't jump very high. The velocity 3.6 is almost horizontal. Otherwise, you can't do it. This question, with, not given the angle of the velocity and so on. Okay, so in that case, after it jump and land on this the log, so basically, so the question is actually asking for what is the final velocity of both. So then the person must be right now sitting on it, right? Let's just assume he's sitting on it. Okay, so it's asking for the V final here, so I didn't put a 1 or 2, is just the total final velocity. Okay, now you still look at the two state, initial and a final. The final state is, of course, means after the lumberjack lands on the log and then they're moving together, and then the initial state is the state just before the lumberjack lands on the log. Okay, so we still have this mv1 initial plus m1 m2 v2 initial equals, okay, now finally be careful, so m1 is gonna have the velocity v final, m2 is gonna have the velocity v final as well. They're both moving together, right? You don't have to have two variables. And of course, look at the, check the v initial. V initial is the velocity of the lumberjack just before it lands on the log, so this is not 0, but v2 initial is 0 because the second log is also at rest initially, so this is 0, right? Okay, and then you can see, you can factor vf out, so you would get m1 is 98, v1 initial 3.6, and then factor the vf out, so inside you got m1 plus m1 plus m2, we'll replace them with number plus 230 and a v final. Okay, so and easy, calculate this, so you should get 98 3.6 divided by, add it together, so 98 plus 230, so you should get a 328, and then you calculate 98 times 3.6 divided by 328, you should get 1.08 meter per second. Okay, this time the velocity final here equals a number less than this, and it's positive. And that makes sense. Okay, first of all, because they're both moving, so you don't have the big velocity, but you still have the same momentum. Look at this equation right here. So that's the total initial momentum, that's the total final momentum, because you have more mass, so velocity doesn't have to be that big as this. And another thing is it's positive, so that means the V final is having the same direction of the 3.6 here. That makes sense, of course, it's gonna be that way. Okay.